According to the Food and Organization (2020), inland aquaculture produced more farm fish, producing 51.3 million tons, or 62.5% of the world total, mainly in freshwater, compared to 57.7% in 2000. The share of finfish production decreased gradually from 97.2% in 2000 to 91.5%, or 47 million tons in 2018. But production of other species groups increased, particularly through freshwater crustacean farming in Asia, including that of shrimp, crayfish, and crab. Aquaculture in Malaysia also shows signs of increase as aquaculture production of Macrobacterium rosenbergi, or giant freshwater prawn, increased from 318 tons in 2012 to 457 tons in 2013. This marked the increasing requirement of freshwater crustacean culture in response to global requirement of increasing global population. However, one of the prevailing issues in giant freshwater prawn culture is water quality, as these prawns are susceptible to disease due to deteriorating environment conditions. This research aimed to discover the impact of water quality on giant freshwater prawn growth and survival rate, thus increasing culture yield. Literature review: Effect of salinity on survival and growth of giant freshwater prawn, Macrobacterium rosenbergi, by Chan et al. 2015. This journal explored the effect of multiply level of salinity effect toward the survival and growth of juvenile Macrobacterium rosenbergi, ranging from 0, 5, 10, 15, 20, 15, and 30 ppt. Additionally, this journal also explored the median lethal salinity by directly transferring test species to 21, 22, 23, 24, 25, 26, and 27 ppt salinity for 96 hours. The journal found that the Macrobacterium rosenbergi could also survive wide range of salinity and start experiencing mortality on salinity more than 30 ppt. Secondly, effect of salinity period and light spectrum on larval survival, growth, and related enzyme activities in giant freshwater prawn, by Wei et al. 2021. This journal explored the effect of salinity on giant freshwater prawn during multiple stages of life. It also explored the effect of photoperiod light spectrum on survival during larval stage and growth. This journal held of Nepro Norvis gigas and Macrobacterium nipponense from the same genus as giant freshwater prawn indicate the importance of water salinity on growth and survival on crustacean species. The results find that the survival rate of 10 ppt and 13 ppt salinity are significantly higher than 16 ppt.
The background of this research discussed the importance of water quality for the growth and survival of freshwater shrimp in aquaculture system. This study aimed to understand optimal water quality parameters such as DO, pH, salinity, temperature, and nitrate level. The main focus is to evaluate the growth performance, survival rate, and feeding efficiency of freshwater shrimp, as well as to identify optimal conditions for shrimp farming in aquaculture system. Main objective: impact of water quality parameter on growth and survival rate of shrimp in aquaculture system. First is evaluate the growth performance, survival rate, and feed efficiency of freshwater shrimp in aquaculture system. Second is analyze the water quality parameter of freshwater shrimp in aquaculture system and identify the growth optimal condition.
In this slide, I'm going to talk about the methodology for our research writing, which first of all, I would like to introduce myself. My name is Onisha Avimekis, BS221605223. The first methodology for our research study is the measurement of physicochemical parameters of water. The second method is by sampling and growth performance analysis. The last methodology will be the growth and survival rate of calculations. First of all, the measurement of physicochemical parameters or of water quality. The water quality parameters proportion or component will include temperature, pH, and DO levels, which will be checked and recorded daily, at least once or twice a day, including morning and evening, using these multi-parameters shown on my right side. The next slide shows two types of parameter device, which the left side is a parameter device specific for salinity levels, and on the right side is a parameter device which is gonna read the pH levels and the temperature for the water environment. Second method is sampling and growth performance analysis, which includes survival rate and growth rate observation. First thing first is the observation of survival rate, where we're using 500 milliliter beaker to get 5 samples at the very least from the prawn tank in different places. Then we contact the total of prawn caught in the beaker for sample 1, 2, 3, 4, and 5. This was done daily to observe the estimation of zoya, larvae, and artemia left in the tank. Below is the calculation for estimation of larvae in our tank or culture tank, which first thing first we need to find the mean, and then we multiply with 2 because we're using 500 milliliter. By multiplying it with 2, we convert the 500 milliliter into 1 liter. And lastly, using the result before, we multiply with the volume of our tank culture. And at the end, we will find the result for our estimation of larvae in our tank culture. Next is the observation growth rate. The experimented prawn was caught as a sample using a thin net and stored in a bucket with an adequate aeration. The prawn was then one by one taken to measure its weight using an electronic scale weight. I forgot to mention, as for the survival rate observation, to increase the accuracy of our estimation of larvae, we can use more than just 5 samples. Yeah. In the next slide shows two devices that was used for survival rate and growth rate observation. The first one is on the left side, called the counter, used for counting larvae artemia that was found or caught in the 500 milliliter beaker. And on the right side is the electronical weight scale. The last method in our finding is the growth and survival rate calculation, which include the weight gain calculation, WG, the survival rate calculation, GSR, and lastly is the specific growth rate calculation, STR. First thing first is the WG, the weight gain. How do we find the weight gain? First thing first, we need to record the weight of the prawn at the current time and the initial weight, the before we started, and we subtract the weight of the current time with the initial weight, and lastly we will get the weight gain. As for survival rate calculation, SR, the NT here is referring to the total number of live prawn at the end of the experiment. Meanwhile, for NO is the total number of PL. By dividing NT with NO, and the result will be used to multiply with 100 to find the percentage of survival rate. I'm sorry, the PL here referring to post larvae, which is the last stages for the zoya or larvae of the prawn. Lastly is the specific growth rate, SGR, where the WT here is the average individual body weight of prawns at the end of the culture period. Meanwhile, as for WO is the average initial body weight of prawn, and T is the duration of the experiment days.
This is the result of water quality analysis of Macrobrachium rosenbergii freshwater shrimp culture in different experimental ponds. The parameters measured include temperature, pH, DO, alkalinity, and nitrogen compounds. Among the three groups, the three show the best water quality with the lowest ammonia concentration at 0.23 plus minus 0.06 milligram per liter, and nitric at 0.42 plus minus 0.07 milligram per liter, and T3 also had the highest flock volume and phytoplankton levels, indicating better biofloc activity that enhance water quality and support shrimp growth. Now let's move on the result for survival rate and growth performance of freshwater shrimp Brachium rosenbergi. The first is shrimp in T2, T3, and T4 groups achieve higher final weight compared to the control group T1. The highest final weight was observed in T3, recorded at 53.48 plus minus 8.23 grams. In terms of survival rate, all experimental groups show high percentage, with T2 achieving the highest survival rate of 88.85 plus minus 1.84%. Lastly, we examine the feed conversion ratio FCR as an indicator of feed efficiency. The best FCR was recorded in T4 at 1.40 plus minus 0.02, reflecting efficient feed utilization. So these results highlight the positive impact of biofloc technology and optimized condition on shrimp growth, survival, and feed efficiency.
And for the alkalinity decreased slightly from tank 1 to tank 3. Alkalinity acts as a buffer to stabilize pH and support biofloc activity. The reductions in the tank 3 suggest enhanced nutrient cycling, as bioflocs tend to utilize carbonate ions for microbial processes. Next is the hardness result. Tank 2 had the highest water hardness, while Tank 3 showed slightly lower levels. Lower hardness in Tank 3 may be linked to the activity of microorganisms within the biofloc system, which utilize minerals like calcium and magnesium for metabolic and structural processes. And then the next one is the total ammonia result, which is the tank 3 had the most ammonia concentrations, which is critical because high ammonia levels are likely toxic to prawns. Part of the table 2. So for the tank 1, which is the tank control, the shrimp in the control group had the lowest weight, and this shows that without biofloc, the shrimp receive few nutrients and grew less. And in the tank 2, tank 3, and tank 4, which is the experimental groups, all experimental groups had heavier shrimp than tank 1, and the heaviest shrimp were in tank 3, followed by tank 4 and then tank 2. Tank 3 performed the best because the biofloc system provides the most nutrients and improved water quality. The next result is in the table 3, which show the survival rate. Survival rates were high in all groups. All groups had survival rates above 86%, which means the conditions were good for shrimp to stay alive. However, Tank 2 had the highest survival rate, slightly better than Tank 3 and Tank 4. This suggests that the Tank 2 systems was a bit more stable for survival. And then next is the result of table 4, which is the feed conversion ratio, or known as FCR. Firstly is the tank control. The control group had the highest FCR, meaning that the shrimp needed more feed to grow. And for the tank 2, tank 3, and tank 4, which is the experimental groups, the biofloc groups had lower FCRs, meaning that they use feed more efficiently. Next, my name is Florina Elena Liu, and I will present about the discussions of the water quality parameters result. The first ones will be the temperature. The temperatures across all treatments were stable and similar. This consistency ensures that temperature was not a stress factor for the prawns, as stable conditions are critical for their metabolic processes. Next is the pH. The pH levels were all slightly alkaline, which is suitable for the optimal health of prawns. The tank 3 showed a slightly lower pH, likely due to the biofloc activity producing organic acids as part of the nutrient cycling process. And then for the dissolved oxygens, the dissolved oxygen, which is known as DO, levels were similar across treatments, and it is indicating that aerations was sufficient for all setup.
In conclusion, multiple research has shown to show connection regarding the effect of multiple water quality parameter that has effect on giant freshwater prawn growth and survival rate. Research find that giant freshwater prawn Macrobacterium rosenbergi could tolerate a wide range of salinity level ranging from 0 to 30 ppt without experiencing major mortality. On the contrary, at salinity level more than 30 ppt, giant freshwater prawn will start to experience mortality. It also finds that 16 ppt have the greatest survival rate compared to 10 and 13 ppt. Additionally, prawns show the best survival rate when ammonia level is at 0.54 mg per liter. That's all. Thank you very much.